Okay, so I wanted to take you through the creation of a packet. When we go from layer three and our application makes a request, and the network stack will break that packet up into data chunks and wrap a layer three header around it. We're gonna just see what happens. I'm going to take you through that network stack, and we're just going to get an idea of what happens in the art process of the packet generation. So I want to take you through it just step by step and let you see what that looks like. And so what we're going to do is I have a little help here, and I have an example of my this is my sample network, and I have this sample network broken up into sections that are this will be a layer two network or a LAN right here. Now, each one of these devices are going to have a network address. We look at the IP addresses and we assign an IPv4 address to each device on our network, and those addresses in the network have to be unique. Just like on layer two, the MAC addresses have to be unique in this switch segment. And what we'll do is we'll kind of see why that is. But as you can see, I have this LAN segment. I have circles drawn around it to indicate that the packet is on that local segment, and then it gets up to um, a router, and that router then makes a routing decision, and ultimately we'll probably place it on this other link right here, in which it will have another layer two header added onto it. And so we're just going to watch and see how that process actually occurs. And I'm going to start, and I'm going to pretend that my PC is PC 0 right here. And so I'm going to show you what that looks like as we go through this. So let us just say that we're going to start and we have some data. And I don't know what it really is. It could be any number of things. What it would look like in a packet is it could look like any number of hexadecimal values. Okay. And we're just going to say whatever that is. I don't know, some text string. But what I'm going to do is I'm going to represent that in the example as this word data. And so it will always be whatever that is for this example. So if I have some data and my application wants to send it, now I really don't know what application it is at this point. It could be a telnet application, it could be an SSH application, it could be a web browser. It doesn't matter. At this point, what I'm going to do is I'm going to have some data that basically my network layer says the layer above here, this is the layer 7, basically, passes it to layer 6, 5, 4, right? All of a sudden, you get down to the network layer, and it says, okay, we want to send this data. Now, it's the network's layer job to figure out how much data we have, and it may or may not need to break that up into pieces. But at this point, we're going to say that it doesn't, and we have data. And what I have to do is I have to figure out, obviously, my web browser, my application is going to be sending a um, my transport layer is going to be sending an IP address or an identity of where that particular data is destined for. Okay, and that's going to be another system on the internet. It's going to send it with an IP address. Now, there could be an IP address that actually is looked up, but in this case, we're just going to know what it is. So in this case, I'm going to say that my PC 0 is going to be me. So I'm just going to use this IP config command to actually look and see what is my IP address. Now I have a lot of interfaces here, but in this particular case, my IP address is a private address 1068.10.100. Okay, so PC 0. Ah, 1068.10.100. Is that right? Yeah, 1068.10.100. Okay, so this is my source address. Remember, an IP packet has to have a source and a destination. And we're going to say that PC4 is 10.68.10.101. Now, it just so happens that PC4 is on the same network as PC0, and we don't really know that for sure. We can kind of guess because the IP addresses are contiguous to one another. But to truly know the answer of whether or not these PCs are on the same network, we would have to have a net mask. So my net mask in this case is telling me which digits I can match. So essentially, all these digits here, they match. And this says this is the network, this is the host, this is all ones, this is zero. So I have some different hosts here that are on the same network. So that is when we get into IP addressing and subnetting, we'll get to learn how to distinguish which one's local and remote. But in this case, we just know that it is local. And so I want to send some data, which is really this right here. I don't know what that is, but it's in data. I want to send it from here to here. Okay, so at layer 3, this is my layer 3 address. What I have is a layer 3 packet, and it has a source, and it has a destination. And there's some other stuff in the packet, right? You know, it's a 20 byte header, right? So this is just 8 bytes worth. And I have some other data and a total of 20 bytes. And then I have data right here. Okay. So um, here's the question. I want to get my data from 4.101 to 0. Now, I know that that's a local because I can look and say, oh, our subnet masks are the same and these are the same, right? So my computer knows, hey, this device is on the local link. So I get to go and look at something called a routing table. Now, this is my computer's routing table, and it shows me when I have a particular address, um, where is that address local or remote. So I can see that that I would use this particular interface address to get this packet out. So what I'm going to do is I'm going to go ahead and issue an ARP request because I'm going to pretend that I don't know what PC4 is. So an ARP request, as I talked about earlier, is kind of like a DNS, right? We use it. We create a packet, and what we do is we go ahead and send it out to a broadcast address. Who is? It basically says that. Okay. Now that goes out to every device. And what happens is that the network card receives it, understands that it is an ARP request, and is looking for this number. Now, whoever that is, and it says tell, okay, so that's pretty much it. The destination, this is the source MAC. The destination MAC is whatever my PC's MAC address is. And I can find that when I look at the interface configuration. Here's my PC's MAC address. Oh, I had that wrong. So I'm going to put that there and then change them. Okay, so this is my layer 2 frame. And this is my layer 3 frame. This is actually my layer 3 frame here. And okay, so essentially what I've done is I've taken this message and I have given it an IP address of the destination, which is a broadcast. Source is me. And I put it on the wire and I've gone ahead and put a MAC address. This is so that our switch can deliver it to the right PC. Right? It goes right from the switch over to the PC. And the way it does it is basically this port, because it's an ARP request, it's a broadcast. So it's going to go out every port except the one it came in on the switch. And then it jumps over here. It does the same thing. It goes out every port except for the one it came in. It goes to this switch. It goes out every port except the one it came in. It gets to PC4. PC4 sees that it is a request for it to respond. And it does, and it creates a unicast packet back to PC0. And it's a response that gives it an IP address. Now, what I do with that at that point is I will go ahead and take that ARP packet or address resolution protocol packet, and I will put it in PC0's ARP table. So it's in the ARP table. I won't have to look it up anymore until the ARP table times out. And I don't have that PC in my ARP table, but if it was in there, it might look like this right here. Now that's a broadcast, but it could look like a second entry on this. It would say dynamic. It would have PC4's IP address and then PC4's MAC address right there. Now, all I have in this case is a broadcast address in my ARP table and a gateway address in my table. So I don't know anybody else on the network segment. I haven't tried to communicate with any other devices that are on my local network at this point. So I don't have an ARP entry here for any other device. I do have an ARP entry for the gateway, and we'll talk about that in a minute. So at this point, what I've done is I've added an ARP entry to PC0's ARP table. Now I'm ready to actually send the data. At this point, my data is waiting so that I can package it up. And I'm still waiting for this destination address, for this destination MAC address. So I could, because I know where I want to send it, I want to send it to PC4, right? So I have created that on a layer 3. So this is my data packet. It's sitting here waiting for packaging, okay? But look, in order to get it on the medium, in order to get it on the cable, I got to have a MAC address, because here's why. Layer 2 switching layer does not know about IP addresses. It doesn't speak that language. We have to communicate in a language that the layer 2 knows how to speak. So we have to have a destination. We have to have a destination MAC and a source MAC. Now, source MAC is obviously my MAC address. And I'm just going to say that my destination MAC is this one right here. We're just gonna figure that out. I'm gonna change it up. Let's see, we'll make it a different number. This is gonna be PC4's MAC address, and we'll make it Alpha Delta. Okay. It doesn't matter whether these are upper or lower case. They're not case sensitive, but I'm gonna make them that way for consistency. And so now I have wrapped this layer 3 packet in a layer 2 header, right? And so I'm going to put my stop bit and my checksum here, right? So here's my layer 2 header, here's my layer 2 footer, inside the data, here's my IP, here's my network packet. And my layer 2 switch understands that it can read this and immediately know how to switch that out, right? So it's also read the R packet, and it's made sure that it knows um, when it goes here and tries to find the MAC address, doesn't exist on that switch. So it goes out this address right here and out that one right there, and then the switch knows the devices that are connected to it, and so it immediately switches onto PC0. So when PC0 gets this message, it can take this header off. And all it's looking at is a network packet right here. And it goes, oh, yeah, okay. So you sent some data to PC4. Okay, well, I know how to deliver that data now. And what it does is it uses a table of open connections. Now, in this case, I have a lot of open connections that I can look at, and Windows keeps tracks of that for me. And this is how the network stack knows, for instance, how to communicate and take information from a recipient and put it up the stack to the destination. It knows where to send it. So this is another way of keeping track of that information and passing it up. And it's all in tables in memory. So all of these things are tables in memory that get modified based on what happens on the network. So remember that this right here is a layer 2, and it only exists between a PC and a switch. Once it hits a router, and we're going to go and look at that, exactly what happens when, um, in this particular case, I wanted to send some data to a device that was on my local network. So in the next example, I'm going to send some data to google.com. All right, so PC0 is here. Google.com is my destination. Now, just like using an ARP, what happens is, which is an application layer protocol, DNS is an application layer protocol. DNS will convert what I type in here to an IP address. And we're going to see what that looks like again when I've done this before, but we're going to use nslookup. And we're just going to do a little query. We queried a server, and it gave us what we wanted. We wanted an IPv4 address. And so in my memory, I just convert that into that destination address. And so I don't have a network here. It's off the network. So my network card goes, oh yeah, okay. So when I look at this IP address, nothing matches. You've told me to look for things that match these values to be my network, and nope, nothing matches. So it has to be remote. Yep, that's what my PC does. And it says, okay, now that I know that this packet is remote, I need to go ahead and I'm going to send some data, right? I'm going to go ahead and package that data up. I need to go ahead and create a layer 2 header to go onto this packet. It needs a destination and it needs a source, right? I have to get it, I have to transport it over the connection. So what do I do? Now, this particular device is a router right here. This interface on this router is actually like any other interface on any other device, except for the fact that it actually is a router. So in our configuration on our PC, we've told the PC about this thing called a gateway. A gateway is like a default route. It means if you don't know where to send a packet or if it's off the network, you need to go ahead and send it to the gateway. So we're going to look at this here. So I'm going to go through this same process again. And I know that my MAC address is this. So I'm going to put it here. Now the problem is where am I going to send this packet? Okay. So I've got to try and find a way to do this. Now, here's what we know. When we look at our IP configuration, and I'm going to go up here and look at that, and I can see that in my IP configuration, I've got a couple of things. What I'm looking for here is I'm looking for the default gateway. All right. So here's where I want to go. Now, I don't put this in the layer 3 header. What I want to do is my PC wants to use this information and it wants to look it up in the ARP table and see where we're going to send it. So we know that if the location is off the network, which it is, we're going to create a packet to our default gateway. So I'm going to look that up in my ARP table. Now, luckily, what I see is that when I want to send a packet to the default gateway, which is that address, I need to go ahead and create a layer 2 header with that Ethernet address. Right? Remember, this is transport. We're trying to get the packet from my machine to the gateway. So and that's how we get it is the layer 2 header. So guess what? So the switch receives the packet and it sends it out. Now, hopefully we've already talked to the router at some point, and so we have a note that we have communicated with that router. But if we have not communicated with that router yet, then it's the same process is going to take place. Is the packet's going to be forwarded out all the interfaces. It's going to get to the router interface right here, and it will be handled. But at some point we get that packet and we put it on the medium. The switch sees the router MAC address in the CAM table and immediately switches it over here to this router. The router is actually just like any other device on the network. It's just very specialized. It does two things. It strips that layer 2 header off, and now it's looking at a layer 3 packet. Our layer 3 packet is destined for a network that it probably doesn't know about. Matter of fact, I'm going to guarantee you it doesn't know about it. Okay. It's because the only thing that's connected right here is probably my ISP's network, and it's not the same. So this particular router has a special little thing called a default route, and it's kind of like another gateway. It means that if the packet that's received on this interface is destined for another network, then it gets forwarded out the interface that is the default route. So I don't know what necessarily is next. I just know that I need to send the packet out. It's like a game of hot potato. All I got to do is get rid of the packet. I got to get rid of the potato. Okay, boom. It goes on the interface and it bounces and bounces and bounces and bounces. Goes all and bounces probably not the best word. It gets forwarded over and over and over. And eventually it gets to Google. Now I've put Tokyo in that example, but it could be Tokyo, but we'll just say it's Google. And Google now knows um, how to respond. Now, in this particular case, this is still if you have a keen eye, you might realize that this particular address is private. What that router actually will do in this case is it will strip that header off. It will look at that destination address. It will make an entry in its table. It will go ahead and rewrite that header, and it will make it whatever its IP address is given to it by its ISP. And then Google will receive the data, and then Google will create a response. This destination address will be swapped, and it will go to the router, and then it will go back through the chain all the way down. It will get back to PC0, and that happens millions and millions and millions of times a second. But remember, layer 2 headers on the local segment. Every time I go past this router onto another circle, I'm going to get a different set of layer 2 headers every single time. Every time I get to a router, that layer 2 gets stripped off, and I'm looking at that same packet inside. We put it on a different circle, a different set of networks, and that layer 2 header gets different, totally different as we go through the handoff. We play in a game of hot potato. Every time we have to pass the potato on, we got to rewrap it. All right, so I hope this helped you understand the layer 2 and layer 3 and how the packet transits through the network. It's relatively simple, but it does take you a little bit of time maybe to kind of wrap your mind around it. So thank you very much.